All right, guys. This is two examples of graphing inequalities and graphing system of equations. I'm just gonna hit the graphing part because you'll be tested on it soon. So we won't worry about algebraic, the addition and substitution method till next week. Okay. So when I hit this again, it's been a while since we've last seen one of these, so we have to kind of review here. There's two rules for graphing inequalities. Now, other than the sign being different, right? This is what tells me that it's an inequality. These are called equations, equal signs. They function just like equations, except for two things that we have to remember. When we divide or multiply by a negative number, flip the inequality sign. Okay? Flip this one. So if it's opening that way, flip it the other way. Here, the second portion is, how is my line going to look like? Is it going to be a dashed line or a solid line? Now, I graphed it earlier, but I messed up the video. So, and this was hard to do, so I just left it there and I'll explain. This is not in y equals mx plus b, right? Y equals mx plus b is close, but I have this -2 hanging out here with the y. I just want to know why. So, to get rid of that -2, I'm going to divide everything by -2. And here I would just get 1. So I'm left with y. Now notice, look at this rule. Divide or multiply by a negative number. Did I divide here by a negative number? Yes. So it no longer opens that way, it opens that way. I'm gonna bring this down a little bit. Opens this way. Okay, this would just be a -3 over 2x. Positive and negative would be a negative. 6 divided by 2 would be 3. Now we have it in the form that we like. This is my slope, right? The number next to the slope, to the x's slope. This one would be your y-intercept. So this is where we start. We start with the number without the x. Okay, and this is y-intercept. And we start there, that will be on this y-axis. So your first point should be on the y-axis at -3. So if this is 0, 0, and this is positive, this is negative, I would go down 3. 1, 2, 3. And that's why my first point was there. Then once I locate my first point, starting from that point, I look at my slope here, -3 over 2. So if I'm saying -3, well, I'm gonna rise over run. So right, this is rise over run, okay? I'm going up and down to side to side. So here, starting from the first point, I'm gonna go down 3, 1, 2, 3 because of the negative, and then to the right 2, 1, 2. That's why my point is there. I can also go, starting from the first point, go up 3 to the left 2. Up 3 to the left 2. Up 3 to the left 2. And that's how I got my points. Now, does not have an equal sign, so my line will be dashed. That's why it's dashed. And we're gonna shade underneath the graph, because if we were to read this from left to right, this closed section will be less than, this open is greater than, right? The alligator always wants to eat the larger number. So this would be less than. So my y values, let's just say, my y values are less than my line. Less than, so if I were looking at this line that runs forever, will it be less, would my y values be less below the line or above the line? This dashed line. Well, all the numbers up here will be positive. Here, the lower I go, the more negative. That's why I shade on the bottom, because my y's are less than. My y's are less down here. And that's it. We do a similar process here, almost identical, right? Instead of these rules, I try to solve for y. Here's my y, and I have to move the x and the -3 to this other side. So I'm going to stress again, if your y, if you're solving for y, and your y is on the left side of the equation, leave it there. If it's on the right side, leave it there. Don't move the letter or variable you're solving for. Move everything else. So I'm going to move that x first and subtract x to both sides so that this cancels out and becomes 0. So I'm only left with the -3y equals. Now, these two are not like terms. This is a -6, which is a constant. This is a variable. So I just rewrite them. I'm going to write -x minus 6. Now, I like to put the x first because usually it's mx plus b. Still haven't solved for y. Okay, so last step would be to move the -3 by dividing by -3 to every term. I have the same number over dividing by itself, that's just 1. A negative with a negative, positive. Here, negative with a negative, positive. And that's x divided by 3. In other words, 1 over 3x. Negative, negative would be positive. 6 divided by 3 is 2. So this is my first equation. These are systems, so I have to graph both of them. For this one, here's my y on the left. Keep it on the left. So I'm going to move everything else, like this this 2x, by subtracting it, so that becomes 0. And I'm left with a -y equals. And these two are not like terms, so I'm just going to write that. -2x, that's a +3. +3. I have a -y, or we could say -1y. Either is both the same thing. But the easiest way to kind of like see this when it's just a -1, and we're trying to get rid of that negative y and make it into a positive, let's just change the signs. So I'm going to make, if it's a negative, I'm going to make it positive. If it's positive, it will be negative. So I'll rewrite this here. If that's negative, I'm going to make it positive. -2x, it is now a +2x. A +3, now it's a -3. All I did there was multiply or divide by -1. That's all I did. Divide by -1, divide by -1, divide by -1. But since you're divided by 1, it's just like changing the signs. And this is my second equation. Therefore, I can graph both.